Okay, in this video we're going to look at more difficult types of trig equations. We've looked at the basic ones in our Zoom class. These are going to give us our more difficult ones. So first thing we need to understand is how a trig function works. So the graph of a trig function is a repeating graph. It crosses the x-axis, so this is the graph y is equal to sine of x. We can see that it crosses the x-axis at 180 degrees and again at 360 degrees, upon which time it comes back to its first repetition. So there's one repetition of the sine graph between 0 and 360, and then it's going to repeat itself again. When we are looking at, for example, y equals sine 2x, what happens with this graph is it doubles the number of repetitions between 0 and 360. So this time it'll cross the x-axis at 90, 180, 270 and 360. So it'll get back to its original point after 2 full rotations. This affects how we solve trig equations. For example, if we're looking at, so the maximum of a sine graph is 1. So if we're looking at when does a sine graph equal a half, we are looking at 2 possibilities here between 0 and 180. And we know that because remember on our unit circle, sine is positive in the first quadrant, which would be between 0 and 90, which would be in this one here, and again between 90 and 180, which is this one here. The issue is this still remains as a maximum of 1, whereas if we're looking at sine 2x is equal to half, we now have 4 possibilities. So it'll be somewhere between 0 and 45, somewhere between 45 and 90, somewhere between 180 and 235, and then somewhere between 235 and 270. So, or 215, sorry, and 270. So what we need to look at is how to solve this. So we have a number of steps involved. The first step is, so say for example, we are looking at solving the equation sine 2x is equal to a half. Our first step is the same as before. We look at identifying the quadrant that the sine is positive in. So we know it's positive between 0 and 90, and it's positive between 90 and 180. And we will be told in these types of questions where our angle measurement is in degrees in this case, or whether we're looking at it in radians, which we'll discuss later. So that's our first step, identify our quadrants. The second step remains the same. We are going to identify the reference angle. So theta is the inverse sine of a half, which gives us 30 degrees. The next thing we do is we identify the equivalent angle in the second quadrant so that we know, so we know that the 2x could equal somewhere between 0 and 90, which is 30 degrees, and the equivalent angle here in the second quadrant is 150 degrees. All right. Now that we know that, we set up our process. So we look at our angle 2x could either be 30 degrees, but because it's a multiple angle here, we have to add a number of rotations. So n dictates the number of rotations, which we'll deal with in a minute. The other option is we have 2x is equal to 150 plus n times by 360, so a number of rotations. So now to get x by itself, we divide across by 2, so we get x is equal to 15 plus n times by 180. Don't need the bracket there, so 15 plus n times by 180. What we have to make sure of is that we divide both sections of the equation by 2. And again over here, we're looking at x is equal to 75 plus n times by 180. When we're dealing with numbers of rotations, so that's just step 1, identify your quadrants. Step 2 is the same, identify your reference angle and your angle in the second quadrant. Step 3, let your angle equal to the angle plus the number of rotations. So remember, a full rotation is 360 degrees. Now that we have the x, we look at how many rotations are there between, how many possible angles we can get between 0 and 360. We always start off with an n value of 0. So that would be 0 rotations. So we're looking at x is equal to 15 plus 0 times by 180, which is 15, or x is equal to 75 plus 0 times by 180, which is 75. Those are our first 2 possibilities for the angle. Next, we look at n equals 1. We're looking at x is equal to 15 plus 1 times by 180. 15 plus 1 times by 180 gives us 195. So our next value of x there is 195. Over here, we have x is equal to 75 plus 1 times by 180, and that gives us a value of 255 degrees. All right. We stop there because if we went to 2 rotations, so if we let n equal 2, 2 times by 180 is 360, 360 plus 15 is 375. Remember, our angles should be between 0 and 360, so if we go to the next number, n equals 2, we have gone above our limit of between 0 and 360, so we have 15 plus 2 times 180, so 360 plus 15 is 375, so we've gone too far, so therefore we stop at n equals 1. A bit of a shortcut for you. The final n value will always be 1 less than the number in front of the x in the original function, in the original equation. All right. So our possible answers for our trigonometric function here, our trigonometric equation, is that x could be 15 degrees, 75 degrees, 195 degrees, or 255 degrees. So that's how we deal with the more difficult versions of the trig equations. Again, just a breakdown of our steps. Step 1, we identify the relevant quadrants where the sign in this case is positive, and so we can get trig equations in terms of sine, cos, and tan. Make sure you identify the correct quadrants. So in this case, we're looking at sine is positive, so therefore it's quadrant 1 and quadrant 2. Next step, step 2, we identify our reference angle in the first quadrant and our relevant angle in the other quadrant. Next step, step 3, we let our angle of 2x equal to our reference angle of 30 degrees, plus we add a number of rotations. We do the same thing for the other angle, 150 plus n times by 360. Divide across by here, so we want to isolate the x, so in this case we divide across by 2. And then we let n equal 0 for 0 rotations, n equal 1 for 1 rotation, and we stop there because if we went to the n equals 2, we've gone bust, we've gone over at 360 degrees. So I'll talk you through more about this in the next Zoom class, but I want you to watch this video and try a couple of questions just to start us off from now.